Okay. Okay, so thanks for coming. I just want to remind everybody that we're recording this. So just for the quality of the recording, we ask that you stay muted and don't use your cameras unless you're presenting. You don't have to, Derrick. It's just an option. And that you direct all of your questions to the Forge Slack live meetup channel. I'll be moderating it and directing all questions to Derrick during the presentation, and then as soon as the recording is stopped, feel free to jump on and continue with whatever chat you want. It's just the current best way to record and produce the video of the presentation. We want to thank Derrick Laird for being willing to speak today and to talk about REST API and some of the standards and procedures of doing that in Go. Derrick is my co-organizer of the Go West conference that is happening sometime in the future. I really need to talk to the one person, so that we can schedule dates again. But he's the mastermind of the conference. I just talk to people. So I'm going to turn the time over to him and let him finish introducing himself. And it's all yours, Derrick.
All right, thanks. Yeah, my name's Derrick. Like she had said, I help co-organize our Go West conference that we're trying to do. It was supposed to happen in May, but because of all the stuff going on, that obviously didn't happen. And we are trying to figure out when to move that to. I also work for a great company called Nozzle. We do a lot of search engine rank tracking and helping people optimize their SEO. So my job primarily is I build a lot of our backend API systems and help build all of our pipelines. So figured I'd do a talk on showing just kind of basic HTTP server stuff, and then kind of move into a little bit of REST and what actually REST is, and hopefully show some do's and don'ts. I have a little bit of an example of what not to do in here. But yeah, let's, I think we're ready to get started. So the agenda here is just going to go over basics, basic HTTP web services, like what is HTTP, do a basic HTTP server, and then kind of build on that a little bit and show more advanced parts of an HTTP web server, go into routing, show a couple examples of testing, and then kind of finish off with an intro to REST and what that actually means to be RESTful. So HTTP is this protocol that is what all these things talk over. So like whenever your browser makes a request to a server, or if you're using an API, you are basically sending one of these requests over. It's just a standard structure for some text, essentially, where you have this start line that says what method we're using, what the path is to that, and then what protocol we're speaking. And then we've got a new line with a chunk of some headers, which are kind of key value pairs. And then we've got another empty line, and then that goes into our body of the request. So in Go, when we're doing these web servers, it's really easy. We just say http.listen and serve, and we provide an address right here saying, take anything that's coming in on 8080 in this case, and then start up our server. So we can kind of show an example here. Run our HTTP basic type. So it's going to start it up, and then the new version of Mac's going to prompt me and make sure I want to actually do this. And we can come in here. If we try and hit this, we're going to get a 404 saying that, hey, there's no content here. just because we haven't actually registered any endpoints. If we look back at our example code here. So we wanted to go actually add in some functionality. This is where we start coming into the adding the routing here. So all of your handler functions or your routes that you're going to define are based around this concept of a handler function, which is just a function that takes in a response writer, which is what we use to write information back to the client, and a request, which is all the stuff they're sending us to handle the request. And in this case, with the standard library, they provide a handler function that just registers a route and your function on a mux that they define, saying, whatever request comes into this path, call this function for me. So if I have an example here where we're doing a /hello and saying, whatever comes in here, let's just write back hello world to the client. Start that one. Handler. So we'll start that up. And we can go into Postman here. For any of you that haven't used Postman, Postman's a great tool to actually view the requests and response when testing servers or building new things. You can see like the type of headers that are coming back, what they're actually sending back, and you can fill out requests nicely and do a lot of really quick iteration on things. So now that we've registered a /hello path and make the request to the server, we get back a world which we've said, hey, when this comes in, let's write back world to the client. And right now it doesn't really matter or what the method is, because when you're doing these endpoints with the standard library, they don't really have any mechanisms to narrow down the method scope, which is where this now goes into to where, say we wanted to implement something like that, we have to do some sort of switch here in the handler function and check what they're actually giving us, and then depending on what came in, determine whether we're doing a database update or whether we're returning back some data, or we're just giving them a generic error that says, hey, this method's not allowed. So in our case here, we're only allowing a GET request. And when they do the GET request, we're going to send back a world response for this hello path. Otherwise, we default to setting them a method not allowed status. So that example here. So again, we do a GET request here and we get a world response back. But if we switch this to say a post, then we start getting into this method not allowed error with a method not allowed status. So that's kind of a lot of boilerplate that you'd have to write every time you want to limit requests down to a method or do something along those lines. This is where the beauty of custom routers start to come in, where someone's kind of written an abstraction layer around this to allow you to have functions that already do that for you. And to do a custom router, all you have to do is create a type that satisfies this handler interface. And if you look back to, well, I guess I'll show on the next slide here. Here where we're registering our server here, before we were just passing in R or nil to the handler when we're saying start the server up and do a nil handler. What that actually does under the hood is if there's a nil passed, they actually will use a default global package level router, and it will register it and use that as the default. So in this case, we're telling them when you start the server up, actually use our new router here that we've defined, in this case, chi. And then all of the requests will then route through this chi handler. And chi here is a router, I guess it's not built by Cloudflare, but It's used by some big companies like Cloudflare, Heroku. We actually use this at Nozzle for all of our web stuff. And we use it to get some specific routing stuff and to make it a lot easier to organize some of this stuff. So in this case, when we're using Qi, we get some nice route registration methods like get, put, post, delete. But we also get a lot of nice features such as middleware. And what middleware is it's basically a function that's going to be called before any of your handlers are called. So you can do some extra wrapping of things, you can add in some context, or you can reject stuff. So in this case, this example here, we are basically checking every request that comes in, and we're checking to see if there's an authorization header here provided. And if there is no value, we return back to the client an error saying that authorization is required for this endpoint. Otherwise, if they did provide some sort of authorization, because our security is super awesome here, we just allow anything that has a authorization header, which then just calls this next HTTP handler that they pass in and tells Qi, the router, to keep processing the control flow chain here, where it's going through all the middleware and then moving on to the handler function. You can also do, so in that last example, that one's just all requests are going to go through this, but maybe you don't want every request to have this authorization wrapped around it. In this case, you can do a function that is taking in a handler, and then you return a handler and do a closure around that. And you're then checking one route at a time. So in this case, where we register the handler down here, we're saying, okay, wrap this handler function in an auth handler, and then it will only get ran if they've provided authentication. Just in the event that you want to have some endpoints that maybe aren't authenticated, and then you don't have some that are. So another nice benefit of using a custom router is a lot of the time they'll provide a method of doing route parameters. So in this case, we can do an endpoint of /book/name, and then we don't have to register tons of different endpoints that are like book/book1, book/book2. We can just define this one that says, hey, whatever's in here, just accept anything, and then we can pull it out with this nice little URL parameter saying, here's the request, here's our key, which we've defined in the route, and then grab the name back. And in this case, we're just going to write the book name back to the client. So we have a little example here, we can show you that. We name that route parameters. Postman. And then in this case, we just do Moby Dick. We get back just a generic Moby Dick response. And it also works if we were to put, I guess, book one, get book one back. So it is dynamic, but we only have to define a single endpoint. So say we wanted to do a more structured data response, say JSON. The way we do that is we define a type, say this is our book struct here with a name and an author. And the way you define what the key or the data structured for JSON is you add these things called struct tags here, where you're saying for this key on this object, which is our book, do a key of name and place this value in it. And then we take our same thing we had before, we create this book struct, populate the book name, and then we marshal that structure into JSON, which is then saved as our data. And then if we had some sort of error doing that, then we'll kick back an error to the client saying, hey, we couldn't write this response or marshal it for whatever reason. And we just give them a status of internal server error because it was something that was probably our fault. Otherwise, we'll set a header saying the content type of this is application JSON, so they know what format this is being returned in, and then we'll write that JSON back. JSON. So if we do that same thing here, now we get back this nice JSON structure that says what the name was, and the author is unknown because this particular API is super useful. So a lot of the, most APIs kind of follow this same format where you're defining an endpoint, you're creating some sort of path here for a resource, you're defining your types of what you want to actually send back to them, and then you're just sending them JSON or receiving JSON. And the JSON works the same way when you're receiving it. You just define your structure of what that is and the format of it, and then you're just unmarshalling the request body coming in. So say we wanted to actually test and make sure our endpoints are doing what we intend. There's a couple ways you can do that. So you can go the route with the HTTP test.server, and what that will do is it will actually create a test server and start running it. That'll bring it up and it'll allow you to hit it with a request to a specific URL, get response back and go that way. Or you can go with this response recorder type to where you create a request and you create this response recorder, which is the response writer, and you pass those directly into your handler, and it kind of goes over the HTTP layer and just kind of cuts out that one layer. So here's an example using the response recorder method, where we define a method here. That's just our generic handler taking in that response writer and request, and then spitting back world to whoever would happen to hit this. We create our new request here, which is going to be a get to this particular endpoint with no body. We create our recorder, which is a response writer, and then we call our handler passing the two in. And then after that's been ran, then we can check our response from the result. That's going to give you a HTTP response as if you had called the done a request via the HTTP client library. And this will allow us to check the response body, verify that we got back what we'd intended, as well as make sure that we got the correct status code back, whether we were expecting a 200 or maybe an unauthorized or whatever it was that we were wanting to check. So now going on to the test server method, this here is where we create a test server. So we're actually saying, here's our new server, here's the mux we want you to use for it, and then we defer a close on that. Now we use the library to actually do a GET request to the test server's address and the path we've defined. Then we do our standard, closing the body, just because you always want to close these bodies that come back from your requests, otherwise they will become a memory leak. Reading that all out and then checking to make sure that the body was what we had expected. You could also do the status code here as well. So now moving on to REST and what that actually is. REST is just a way of designing APIs and a architecture style of how to design those. It was introduced by Roy Fielding in 2000 in one of his dissertations, just saying this is this, I guess, standard or way of designing these systems, network systems. So kind of the key concept here is this idea of resources and resource methods. So a resource is kind of any object you can kind of reason about. So in this case, like a book or your books, a book becomes a resource, and they become kind of pluralized in this format here. And then you have your methods or resource methods, sorry, that define like what I want to do with this particular resource. So like in the case of a post, we want to create a book on this /books resource. Get, we want to retrieve all the books. If we add an ID, then we want to get a specific book from this resource. If we're doing a put, then we want to update, delete, patch, etc. And the reason this is important is if we start going into this Richardson maturity model that kind of shows how RESTful something is, you'll see at level 0 that things are kind of this really big mess and it gets really hard to reason about things. So with the Richardson maturity model, you have 4 levels here to determine how RESTful something is. At level 0, we have this swamp of POCs, which is plain old XML, which is just a big single bucket of these endpoints. And then it slowly progresses through each one of these steps to become more fine-grained and defined. So looking at this level 0 swamp of POCs, we have a single path, which is just using Twitter as an example here. We have /Twitter. And everything going in is this XML type blob that is create tweet, we'd have delete tweet or update tweet or whatever. And you can see how that kind of would eventually kind of get out of hand where we have to keep defining all these new message types, all just going into this single thing, and you don't necessarily know what your options are to do with that. So then we move on to a resource-based address /URI, and this is where we start breaking things out a little further and becoming more defined, saying, okay, we have /Twitter, but now let's be more defined and say we have /tweets, and we can have a tweet ID, and then you can get the comments for that tweet or the followers, and you can kind of see this hierarchy, so to speak, of starting at a tweet and working your way down to the child parts of the tweet. And then once we move on to level 2, now we're starting to utilize the full HTTP protocol and use methods. So in this case, we can do like a delete on the tweets with a tweet ID, and we'll get back a status code saying whether I was successful. We could delete a comment based on just the path, or we could create a tweet by posting 2 tweets. Then you start getting into this really in-depth level 4, I guess, which is 3. And what this does is you're starting to actually send back to the client more detailed responses saying, here's like your tweet response, and then here's all the URLs to actually get the next step should you want it. So in this case, they're returning back a link that's for the comment and showing how to, or here's the URL you would hit to get the comments for that tweet. And here's an example of that with GitHub. So this is hitting their search commits endpoint. And when they give you back this commit thing, you can look at the committer. And on this committer, they show like, here's the URL to get to that committer. Here's the URL to see their followers. Here's the URL to see who they're following. Here's to see all their gists, what things they've starred, what their subscriptions are, what organizations they belong to, see their repos. So it's kind of self-documenting in a way that you just make this one request and you get back kind of the story of how to get to the next phase, and you're not having to figure out what that is. So moving on to an example of what not to do here. I actually ran into this a couple days ago with Sentry.io. Hopefully no one in here actually works for them or anything. So here they've got a few endpoints defined for creating this project, which is one of their resources. And you can see that, okay, here's a get, I can retrieve my project. Here's a put, I can update it, a delete. So we would think that we could hit projects with a post, and that would create us a project. And once we try that, then we start getting a 405 method not allowed and kind of wondering, okay, what's going on here? How do I actually create that? And then after you've stumbled around the docs for a little while, then you end up at this example here that is, oh, they actually have it under a team. So you create your project under a team, and then you still interact with the project that's been created via the other endpoints. So there's not really, you don't know that without actually going through all the docs, and it's not very self-documenting or easy to reason about. On top of that, they also, when you create it under the team, the response they give you back is different than what would be returned up here in the get on the project level resource. So they are an example of, yes, they're pretty close to being RESTful. They're mostly there. They just could organize things a little bit better. Here's a couple resources. This great post on Red Hat. If you want to read more about this Richardson maturity model and go in depth on what the different parts of it are. And then we've also got here REST in detail, a great article here by Code Academy. And it goes, there's actually 6 individual parts to REST. I didn't think it was really a fitting time to go through all those and go into detail with those. But should you want to read about that, you can by reading that article. That's all I have. Sorry it wasn't more in depth. I had planned on doing a nice interactive demo and building out a little project, but because of all the stuff going on, that wasn't really doable, and I didn't think it would translate well to an online format. If you want to follow me, I'm at MordFustang50 on Twitter. I tried changing that today. There's not many options. But sometimes I post interesting things and share cool things to read.
And talk about Rust.
Yep, and Rust.